Hello, and welcome back to Mr. Abden's Mathematical Adventures. Well, welcome for the first time, I guess. And don't forget to like and subscribe. Alright, we're going to learn how to add, subtract, also known as finding a difference, and multiply two polynomials. What's a polynomial? Polynomial is this a number with many parts? Poly meaning many, nomial meaning number. Then sometimes there's actually not many parts. Like 5 is technically a polynomial. The other parts are all 0, so we don't see them. But here's a binomial, two parts, the x and the 5. In fact, let's take that polynomial, x plus 5, and let's add another one. How about x minus 3? And then later we'll find the difference of those two, and lastly we will multiply them. So the first thing I want to draw your attention to is right here, this symbol. Here we are adding them, here we will subtract them, and here we will multiply them. There's no symbol here. There's a little dot in there if you want. Mathematicians love multiplying so much. When we don't write anything, we mean multiplying. It's fun. Okay, so this is pretty simple actually. If you're just adding two quantities, you just count up what's in there. There's an x, there's another x, 2x. There's a 5, there's a negative 3. Those add up to 2. 2x plus 2. Another way of thinking about it, you don't have to do this, but it might help you just understand what's going on here, is we have one of this group and one of this group. So let's distribute x plus 5. Okay, that group has been distributed. We don't need the parentheses anymore. Plus x minus 3. After we distribute that. And now you just combine like terms. 2x plus 2. In other words, when you're adding, you're basically just combining like terms. Those grouping symbols aren't doing anything because there's just ones out front, so they're very boring. There could be numbers out there, but not in this simple case. When you're subtracting, it's pretty much the same as adding, except the second polynomial is going to be taken away. And so there's different ways of looking at that, but let's put in our numbers here again. We're doing x plus 5 minus x minus 3. And one way people do it is in their heads. They say x, take away x, 0x. 5 take away negative 3 is actually 8. The answer is 8. The x's went away. That doesn't usually happen. I'll do another example here. Let's do a different number. Let's do 3x plus 10 minus 2x minus 5. So we could do it in our head. 3x take away 2x, that'd be 1x. 10 take away negative 5, that's a double takeaway, so add 15. The answer is x plus 15. But we don't want to get confused in here. So you actually can distribute the minus sign, so it's minus 2x and minus 5, which would be plus 5. Other people like to sneak a little 1 in here to distribute a negative 1. So it becomes minus 2x plus 5. Can we do anything with this first group? Let's just pretend there's a positive 1 out there and distribute it. 3x plus 10. Okay, now we can combine like terms. 3x, negative 2x is an x. 10, 5 is a 15. So there's our answer. In other words, you just have to be careful with this second group. You have to flip their signs or distribute a negative 1 or pay attention. Subtracting polynomials is a little bit more work than adding. But it's pretty much the same thing. Just make sure you can figure out what's going on with the second one, the second polynomial. Multiplying is the funnest. So let's do our original polynomials, x plus 5 and x minus 3. Basically what this is saying is everything represented in this quantity is going to get multiplied by everything representing in this quantity. So everything over here gets multiplied by over here. But everything over here also gets multiplied by over there. So this x has to be multiplied by x and negative 3. So we can use rainbows to keep track of that. X times x, that's x squared. X times itself, x squared. But also, x needs to also hit negative 3. It needs to be multiplied by negative 3. That's negative 3x. What about the 5? It hasn't gotten multiplied by anything yet. Let's do that. 5 times x. That's 5x. And it hasn't gotten multiplied by the negative 3 yet. Negative 15. Now you can combine like terms. There's nothing like x squared. X squared and x are different. They're related, but they are different quantities. So we cannot combine them together. We don't know what x is, then we definitely don't know what x squared is. If x is 5, x squared is 25. But if x is 6, x squared is 36. So they're not the same quantity. And they cannot be combined when you're combining like terms. When we get to factoring, that's when it'll get interesting. But that's a different story. Alright, let's combine these. These are alike. Those are both the quantities of x. Negative 3x's plus 5x's. 2x's. And this negative 15 has no like terms to combine with. Okay, let's look at a slightly harder problem. 2x minus 5 times 3x plus 2. 2x times 3x. You multiply the bigs, we're going to have a total of 6, but also the x's hit each other and multiply up to x squared. 2x times 2, 4x. Negative 5 times 3, negative 15x. So I did that one, I did that one, I did that one, and the last one, negative 10. Combine like terms in the middle. Ta-da. I'm going to show you another model for that. And first I'll go back and do a little reminder. Middle school. What if I had 12 times 15? One way to do that is to say that I have an amount here, 10 and plus 2. That's the 12. And the other amount is 10 and plus 5. That's the other amount. And these are two sides of a rectangle. And we want the area. How do we get the area? We multiply. So we're going to multiply this. But we can do sub-areas. We can now take this, which represents a side of 10 and a side of 10. That's 100. And this little extra plus 2, it also gets multiplied by 10 to make a 20. Because the side of this is 10, and the top is 2. 10, 2, 10, 10, 2. How about this area? The top is 10 long. We can see that from up here. It's 10, and that's 10. And so this times 5 makes 50. And this last little box, my favorite little box, its sides are 5. I can see that from over here. And 2, I can see that from up here. And that makes us 10. And I can add it all up. And 100, 180 is the answer. That is what 12 times 15 is. So we can do a similar thing when we have 2x minus 5 times 3x plus 2. We have some amount 2x, but then also take away 5. And we have some amount 3x, but also plus 2. And we set up a rectangle. And we do it by areas. So 3x times 2x, there's our 6x squared. Don't forget the x times the x there to make x squared. And there's that. This one, its edge is 3x. I can see that from here. And the top is negative 5. That's a negative 15x. And that is this quantity. This sub area is 2x times 2, which is 4x. And this sub area is negative 5 from here. And the 2, that's the negative 10. Which is the last little thing. I forgot, there's the 4x. Okay. Oop, sorry. And again, you combine like terms. The like terms in this case are these. So if we write that out now, we have 6x squared. Those combine to negative 11x. And then negative 10. And you can see, same answer. two different methods. This is using an area model, and it's a great system. We'll be looking at that. Okay. Hope you had a great first video. Don't forget to like and subscribe. I'll see you guys next time.